When was the universe the darkest, the most black it has ever been? When the Big Bang happened, it filled the universe with spectacular brilliance. But the moment this glow faded, for thousands of years there was nothing to illuminate the universe. It was the darkest the universe has ever been. This is the chaos of the first billion years. It all started, as everything else, 13.8 billion years ago with the Big Bang. A tiny bubble from a possibly infinite universe started to expand at an incredible rate. The universe grew by a factor of 10 to the 26. It was like a bacterium growing into the size of the Milky Way in a timescale so insanely small that we can't really imagine. The tiny fluctuations of the pre-inflated universe were blown to cosmic sizes. And it's interesting that the universe from the very beginning had these tiny inhomogeneities. If, for instance, the universe would have been perfectly uniform, nothing interesting would have happened for a long time. And here too, quantum mechanics played its part and gave the universe tiny fluctuations that seeded the formation of structures and everything. Anyways, after inflation, the universe was filled in a bath of quark-gluon plasma and leptons like electrons or neutrinos, a soup of elementary particles buzzing around in high energies. However, there's a problem. None of these should actually exist. The Big Bang should have produced equal number of matter and antimatter particles, the two broad categories of particles that we have. And these, being complete opposites of each other, should have destroyed each other completely, leaving behind nothing but radiation. But luckily, that didn't seem to have happened. Somehow, some matter survived. Why? We don't know. But if there wouldn't have been this discrepancy, nothing would have ever formed. The word wouldn't exist. It hints towards a fundamental asymmetry in the universe. There is a very fundamental way the universe very slightly favors matter over antimatter. Consequently, the matter-antimatter annihilations filled the universe with radiation. The universe started to glow. As the universe cooled, the leftover matter formed hadrons like protons and neutrons, ultimately leading to the formation of the nuclei of elements of hydrogen and helium. What time it was? It was still less than 20 minutes since the Big Bang, and we have to cover a billion years, we have to move fast. The universe continued to cool. The tiny disturbances in the distribution of matter led to regions where there's slightly bit more matter and regions where there's slightly bit less. These crafty hotspots quickly gathered a lot of dark matter, which attracted regular matter even more rapidly, streamlining the process of structure formation. At 47,000 years, the universe started to be dominated by matter over radiation. However, the conditions were still too harsh for neutral atoms to form. Oh, wait a minute. We don't have atoms yet? What are we doing? Well, we'll get atoms a couple of 100,000 years later. In the soup of charged particles, light didn't have a free ground to travel. It was like a great cosmic fog where if you would have been there, you wouldn't see anything because, well, light didn't really travel much. But the big change happened. 380,000 years after the Big Bang, the universe finally cooled enough for neutral atoms to form. The first hydrogen and helium molecules were there, and so radiations could now travel freely without bumping into a mass of charged particles, which meant the universe became transparent. This radiation is still traveling around us. It's the cosmic microwave background. However, the ever-expansion of the universe has led to its wavelength getting redshifted to the extent that it's currently in the microwave region of the electromagnetic spectrum. And let me tell you, much, if not most of understanding of the universe comes from seeing patterns of this background radiation, the size of the blob, the frequency of hot and cold spots. It's almost like a projection of the universe as it was back then. And if you would have been there that time, the universe would have looked completely different. This radiation would have been glowing bright orange, and so unlike how we see the universe today as kind of relatively black, that time it was orange. As the universe cooled and expanded, this radiation got redshifted out of the visible spectrum, and so suddenly the universe turned dark. Scary dark. Darkness prevails in the universe. It wasn't until 200-ish million years that the first stars would form, illuminating the universe. In the absence of stars, the universe was darker than ever. The only light was the cosmic background radiation, which had already been redshifted out of the visible spectrum and so not visible, and the occasional light emitted by electron transitions in atoms. Not much. These were the cosmic dark ages, the darkest the universe has ever been. where in the background things were happening, structures were developing, but quietly. To reignite the universe, we needed stars, balls of matter with enough gravity to start fusing lighter elements like hydrogen or helium into heavier ones like carbon or oxygen, emitting light in the process. However, the formation of stars wasn't such a streamlined process. There was a lot going on. Remember those tiny inhomogeneities in the distribution of matter? Those would have acted as gravity hotspot, attracting further matter. Consequently, gas clouds of hydrogen and helium were forged, which would then go on to form the first stars, slowly taking the universe out of the dark ages. However, these first stars, also known as population 3 stars, were a lot different than the stars that form today. They died fighting the cosmic battle. To form stars, the molecules in a gas cloud needs to cool down. When the gas is hot, the particles simply move around too fast for anything to stick together. In the current universe, the gas clouds that form stars have high metallicity, which is to say they have a significant amount of higher elements, which because of their higher energy levels could shed their energies a lot more efficiently, cooling off the gas and allowing stars to form. However, in the early universe, there was simply none. All we had was hydrogen, helium, traces of lithium. They weren't going to do it. And so it was a lot harder for gas clouds to cool down and start forming stars. But all the time, gravity was still doing its thing, and so the gas cloud continued to gain more and more mass. Eventually, though, the conditions got good for stars to form, but all that delay meant that these stars would have to be giants, even as big as 300 times the mass of our sun, or even more. And because these were so massive, they burned their pure enriched fuel extremely rapidly, dying fast, living for only around hundreds of thousands of years, and giving the universe its much needed heavier elements, which allowed the subsequent stars to have a longer life. As time went on, larger structures like galaxies and galaxy clusters emerged. But since then, the universe has looked pretty much the same. Like, it has grown a lot bigger now. Sometimes around 5 billion years ago, the expansion rate of the universe started to accelerate. But overall, it has looked pretty much the same until we came around. Thanks for watching.